Okay, so this is lesson 7.9, which is very similar to last lesson, except we're finding the exterior angle measurements of polygons. So, quick reminder, supplementary angles are angles that sum to 180. So, if you have two angles, for example, this angle here plus this angle here will equal 180 degrees. Okay, so we're going to use that idea to kind of investigate and find out what's the sum of the exterior angles of a polygon. So during class, you might have done step 1, which is finding the measure of each interior angle of the following regular polygons, and then you label them. So quick recap, you know that the sum of the interior angles of a triangle is 180. So to find the measure of one of them, you would do the sum of the interior divided by the number of sides. So 180 divided by 3, which was 60. So 60 plus 60 plus 60 is 180. So then for a quadrilateral, all of these angles add up to 360, right? Because 4 minus 2. So then 360 divided by 4 was 90. Here, all the angles ended up summing to 540. So you take 540 and divide by 5, and you get 108. All of these angles sum to 720. So then you take 720 and divide by the number of sides, which is 6, and you get 120. Okay. So now we're going to extend the side of each polygon in the same direction to create an exterior angle. So I'll show you here. I'm going to extend this side to create this exterior angle here. I will spin my paper and extend going this way. Spin my paper, extend going this way. When you're done, it should look like a pinwheel. So something like that. So I'm going to take a moment and I'm going to do that for all of my polygons. What I'm doing is I'm creating two angle measurements. Last one. Okay, so now we are ready to go. So that's 1, that's 2. Label each exterior angle with an arc and its measure. So I'm going to use a highlighter actually. And if you notice, these are supplementary angles, right? Or we'll look at this one here. This angle and this angle will add up to equal 180. So to find the measure of this angle here, I'll do 180 minus 60, which is the interior angle, to get 120. So all of these angles are 120 degrees. I'll do this one really quickly. So this angle here will be 180 minus 90, because these two angles are supplementary, which is 90. So all of these angle measurements are 90 degrees. Here, this angle will be 180 minus 108, borrow. So that's 72. So all of these angles are 72 degrees. And then lastly, this angle here will be 180 minus 120, again because they're supplementary, which is 60. So all of these angles are 60 degrees. Because again, they're supplementary to the interior angle. So quick recap of that, an interior angle is supplementary to its exterior angle. I'm going to write that down. An interior angle is supplementary to its exterior angle. I'm going to write at the bottom of the page. An interior angle and an exterior angle are supplementary. Or you can say they're a linear pair. That's more specific. Okay, lastly, we're going to fill out the chart that's on the next page and look for a pattern to make a conjecture. So I'll do kind of what I did last time. Our goal is to figure out what is the sum of the exterior angles and is there a formula for it. So a triangle has 3 sides and there are 3 exterior angles. 1, 2, 3. Each exterior angle was 120 degrees. So to find the sum of them, we do 120 plus 120 plus 120. So that's really 120 times 3. And 120 times 3 is actually 360 degrees. So this angle plus this angle plus this angle is 360. Okay, a quadrilateral has 4 sides and it has 1, 2, 3, 4 angles, 4 exterior angles. Each exterior angle measured 90 degrees, so 90 times 4 to figure out what all of these add up to. So 90 plus 90 plus 90 plus 90. And 90 times 4 is 360. Those are the same. Okay, so then a pentagon has 5 sides, and a pentagon has 1, 2, 3, 4, 5 exterior angles. So what I'm noticing is that the number of sides is the same as the number of exterior angles. So I'm guessing this is 6 as well. 6, and it is. Each exterior angle on a pentagon was 72 degrees, and we'll do 72 times 5. So 72 plus 72 plus 72, which is, guess what? 360. So then a hexagon, I'm taking a wild guess, this is 360. 60 times 6, which is in fact 360 degrees. So the measure of each exterior angle of a regular polygon will always be the number of, it will actually always be 360 divided by the number of sides. Yeah, and so the sum will always be 360 degrees. So what conjecture can you make about the sum of the exterior angles of any polygon? Conjecture is that they always are going to equal 360 degrees. And the way that we'll write that is sum of the exterior equals 360 so that we can use it in formulas. So let's do a couple examples. Each of these are just a little bit different, so pay attention to the words. What is the sum of the exterior angles of a hexagon? Well, remember, it doesn't matter what the shape is. If we're talking about exterior angles, they always sum to 360. So yeah, that's our answer. Awesome. What is the measure of each exterior angle? So we're looking for one exterior angle of a regular hexagon. So n equals 6. So if I want the measure of each exterior angle, so I want the measure of one exterior angle, which I'll annotate like this. I'm going to take the sum of the exterior angles. I'm going to divide by the number of sides, right? Because they're all congruent if it's a regular hexagon. So then the sum of the exterior angles is 360, and we'll divide that by 6 because that's how many angles there'll be, and you'll get 60. Right, because remember a hexagon, 2, 3, 4, 5, 6, has 6 exterior angles, and if this plus this plus this plus this plus this plus this equals 360, then to find the measure of 1, we're going to take 360 and divide by 6. Let's do the next two. What is the measure of each interior angle of a regular hexagon? N equals 6. Okay, so what we did last lesson is we had to find the sum of the interior angles, and then we divided it by the number of sides to get the one interior angle. So first we had to find the sum, and then we had to divide it by the number of sides. We're going to do this a new way today. So we know that an interior and an exterior angle, they are supplementary. So what we're going to do is if we can find the measure of this one, we can just do 180 minus the exterior angle to get the measure of one interior angle. So one exterior angle will be 360 divided by the number of sides, which is 6. So one exterior angle is 60 degrees, which means that the interior angle is 180 minus 60, which is 120 degrees. We would have come to that same conclusion another way, but this way was way faster. We found the measure of one exterior angle and then subtracted it from 180 because they're supplementary. All right, the measure of an exterior angle is 40 degrees. Name the polygon. Okay, so I have to name the polygon, which means I need the number of sides. Well, I know that to find the measure of an exterior angle, you do 360 and you divide it by the number of sides. I know that the exterior angle is 40 degrees. So I know that 40 equals 360 divided by n. I'll quickly cross multiply. 40n equals 360. Divide both sides by 40, and n equals 36 divided by 40 is 9. So what's the polygon? It's a nonagon. Last one. So I need to solve for x, and these are all exterior angles. So the sum of the exterior angles is 120 plus 130 plus 2x plus x plus 20. Combine like terms. So I have 3x plus 120 plus 130 is 250 plus 20 is 270. And I know that all of these added together will equal 360 degrees. So I'll subtract 270 from both sides. Borrow. 60 minus 7 is 9. So 90 equals 3x, which means x equals 30. Again, all of these added up would equal 360, so I add those up. It equaled 3x plus 270, and then I solve for x. Make sure you use the answer key to check your work, and replay this video if you need it.